Okay, this is task 5 for completing the homework assignment for lesson 6. We're working on the cafe, and we just finished calculating the sales and the cost of goods sold for the cafe. So you completed all those yellow areas, and it did tie down beautifully with what we had in the financial statements. So now what you need to do is take the data for each area. So we're looking at this line, sales, cost of goods sold, as well as all of these lines for expenses. And we're going to create the scatter graphs again. And so we use the data that's down here to accomplish that. Remember, with linear regression, you use all the data. So highlight that, hit insert, and it's a scatter. Okay, pull that down. Let's color it up a little. Change the title. So this is the revenue graph. Okay. Click on any one of those points, add a trend line. So it's a right mouse click, add trend line, display the equation and the R squared. So every single point is on that line. It's a perfectly positive correlation. And if you look, it's giving you the average, the slope on that line is the price. And that matches our weighted average price that we calculated before. So just confirming what we already knew, $4.23 roughly is the price. And then this crazy thing here is just scientific notation. Essentially, it means 0. So the intercept is 0 in that case. So if you don't sell anything, you don't make any revenue. You don't book any sales. That makes sense. It's 0 at 0 volume. All right, so that's the linear regression result. To do the high-low method, if we do equals min, open parentheses, highlight all the x-axis data, that's the run. The minimum is 10,266. So you see I already highlighted that for you. So again, when you're doing high-low method, you go for the activity level to identify the low point, not the dollars. Don't pick the dollars. You pick the dollar that goes with that activity level. Even if that's not the lowest dollar amount, you still pick that one. So go ahead and grab that down. And then this one would be equal max. And highlight the data. And there you go. And I highlighted that one for you already in green. So grab that dollar amount. Okay, so this is the rise, the y-axis change, and this is the x-axis change. So to get the slope, we take equals the change in this. Oops, I didn't catch that first one. I'll start again. This minus this, divide this minus this. Okay, so there it is again. The slope on that line, M, is $4.23. That's the average price that we get from a sale in the cafe. Okay, fixed cost is going to be equal to the total cost. You can use either the high method or the low point, the higher the low point. So we'll use the high because that's what I usually do. That's the total cost. Subtract out the variable cost and you get the fixed cost. So that is quantity at that same point times the variable cost, which is in cell D52. Sometimes you got to type that because it just isn't big enough. Okay. Here we go. Okay, so the fixed cost is showing you a 0 intercept. Right, so we're good to go. All right, let's do this one. So highlighting all of your data, insert, scatter graph. Your label. This one's cost of goods sold. Okay, so these data points came from that line right there for cost of goods sold. Okay. Okay, so again, the low point is the same. We're dealing with the same x-axis, and the high point is the same. Just the dollar amounts, of course, are for cost of goods sold, not for sales. Same idea. Now, if you want, you just take those, copy, In fact, we could have done it all that way. Save a lot of time. All right, let's also take this. Notice that the points, look, we're a little bit off, right? So let's see what happens. Add a trend line, get the equation and the r squared. So here's an example for you where those points were exactly on the line. Some of them are a little off the line, right? So you're getting an r squared now that's less than 1. Remember, the range on an r squared is 0 to 1. So it's still extremely good model, right? Everything's clustering right up on the line. But it's not right perfectly on the line. Some of them were, that one right there is off a little. Okay, these are off a little. And so that's being picked up in the statistic. Still a fantastic model. Notice the high-low method gives us just a slightly different result, right? Because it's exactly because this is giving you the average of all the points, whereas this is giving you the average of just 2 points, the high and the low. And so the line here is just a little bit, the slope on this is a little bit shorter. It's nothing significant, right? There's not a significant difference. The only time the two, linear regression and the high-low method, give you big differences is when the data is really kind of spread out on the graph, when it's not clustered to the line. Right? You're going to get different results because you'll get different slopes and different intercepts. And you did here, even with just a tiny little change, right? So this is somewhat close, but this is definitely different. 972 versus 679. Okay. Now let's do this. We can copy all of these and get them all done. And then all we have left to do is the graphs. Okay. Easy peasy. Copy the data points, insert, scatter graph, resize, clean it up. Right click on a dot, add trend line. Perfect linear, so notice the results are the same for the high-low. Good. Again, highlight the data, insert, scatter graph, pull it down, resize, and relabel. This is promotion and selling. Okay, that looks linear. Pull that up. It is perfectly linear. You got an r squared of 1 that should line up with these exactly. That scientific notation just means that you have some very, very, very insignificant number there on the tail end. Assume it's 0, because for all intents and purposes, it is. So it's just a slope on this line. This is 100% variable cost, right? 100% variable because there's no intercept, meaning the origin is the intercept. So if there's no activity, like we're not selling anything, this cost is 0. We don't promote and sell, have selling costs if we're not in selling any product, right? So it's a discretionary type of cost. Okay, this one had fixed and variable components. The fixed is represented by the y-intercept, so those are costs that you would incur even if you're at 0 volume, and the slope represents how much your costs are going to increase for every unit that you sell. So you'd incur a cost of $2.34 for every $4.23 sale that you incur, as well as these fixed costs. And we're going to really be working with this a lot over the next couple of weeks, so you can figure out what's the volume got to be in order for me to at least break even. Okay, here we go. Let's keep going. Sorry. Okay. So what do we got here? We got a fixed component. It's an R²1, so it definitely matches what we have for high-low. They always will whenever you have an R²1. The only time they're different is when that is less than 1. It'll be a lot different if it's significantly less than 1. Here we go. Insert, scatter, slide. Okay, this is waste removal. Okay, fixed, right? Fixed cost. Like I said, in a Mac, when I try to do a trend line on that, it doesn't like it. So I'm just going to leave it. I know it's going to be the exact same answer as this. So I'm just going to use this when I get to the next tab, and I have to indicate what the linear regression cost is. Okay, almost done. Repairs and maintenance. That looks very linear. Let's see what it shows up as. Yep, it'll be the same. So it does have a fixed and a variable component. Okay, notice this one looks completely fixed. It doesn't change no matter what the level of activity. Again, I'm not going to create a trend line on that. I'll just use this because they're going to be the same. Again, fixed. We're good to go. Right click. Office. Fixed. One more. And you can wrap up this tab. It's going to be fixed. Okay. So that's it for the 5th task. We got one more thing to do, a very short video to wrap up that last aspect. So we've just sorted these all out. We've got to pull those together. All the variable pieces, we'll add them up. All the fixed pieces, we'll add them up. So we generate a total cost curve formula for all of our costs, which would be very, very handy for us in understanding our business, what costs we incur that are fixed every month, what costs are variable every month, and what that means in terms of driving our volume, right? So what's that sweet spot in order for us to break even? That's where we're headed.